computer. All right, hello everyone. Nice to meeting you. I'm a Professor Ben. I'm a math instructor for your Calculus 3. This is synchronous online courses. What I mean by synchronous, we are meeting every Tuesday, Thursday from 4 to 6 p.m. So you see our beautiful Canvas shell. This is the main page of your Calculus 3. During this time, Tuesday, Thursday from 4 to 6 p.m., I'm giving you guys a live lecture. So as you see that, this is our main page. We have a total of 17 weeks. Oh, I see a lot of people are joining right now. Welcome everyone, nice to meeting you. I'm just beginning explaining our Canvas shell structure, and I'm gonna talk about the syllabus. And then I'm going to give you guys a 1.1 lecture today, okay? So right now, 4 p.m., I just hit the button record. So this is a record for update. I'm gonna upload this video later. Okay, I see a lot of people are joining here. I wish I can see your face. If you want, please type your name correctly so that I can call you, okay? All right, welcome back everyone again. So this is our main page, Calculus 3, Spring 2026. I will tell you one more time. We are meeting every Tuesday, Thursday from 4 to 6. It will take about 2 hours or less than 2 hours because my lecture will be around 60, 70 minutes. And then for the rest of the minutes, I will give you guys a couple questions to practice together, okay? So how are you everyone? This is our 17 weeks schedule. Can you guys see this chart? So this is a synchronous. You have online portion to submit your assignment. So here's all the agenda for every week. So this Tuesday, today, I'm going to briefly talk about the syllabus pretty soon. And then we're going to talk about 1.1 parametric equation. Calculus 3, we are talking about vector systems and other 3D dimensional numbers. So here we have a lot of topics to cover. I'm trying to do my best to cover every topics. Pretty much we're gonna cover the chapter 1, 2, 3, 4, 5, and some part of 6. So we have 6 chapters for this semester. I know it's a lot, but we're gonna work together, so it's gonna be okay. Hopefully you guys gonna work hard, right? So I already post the PowerPoint. So every week we have the same styles of agenda. So 1.1 we're gonna talk about today, and Thursday we're going to master 1.2. If you click PowerPoint empty, this is your lecture notes. Can you guys see my lecture notes right now here? Yes. You can download it to your iPad or tablet or computer, or you can print it out, because I want you guys to really write down your work while I'm giving you the lecture. So this is, your, paper, your net lecture note where you can work on with me, okay? So we have 10, 11, pages today we're gonna cover together. So hold up there. I'm gonna come back this one later. And then every week, of course, we do have an assignment. So once you watch the video and you study with the lecture note, you can go to quiz 1.1 later. This is your weekly assignment, okay? And we have a 1.2 later, same thing. So if you go to home, this is your home main page. Same thing, you can see everything is a reoccurring every week. So 1.3 next week, 1.4. I'm trying to do my best to post the PowerPoint all year before I'm giving you a lecture. So please download it in advance. Okay. Okay, so this is our main page. There's a Zoom link, as you can see. I do have an office hour. You can check it here, but please email me before if you want to make appointment. Okay, so Monday, Tuesday, Wednesday, 1 to 2, Thursday, 3 to 4. And I will talk about the rest of things through the syllabus. So let's go to syllabus. Okay, so this is a transferable unit to, you can transfer to CSU or UC level. This is Calculus 3 with 5 units. And we have a live lecture Tuesday, Thursday, 4 to 6:15 p.m. And as I mentioned, there's office hour, and we have online textbook. I will go to module where you can find out the online textbook. And let me go to module quickly. So here's a student orientation. Please read. There's a meet and greet assignment by next Monday. So basically, you're going to introduce each other. There's a couple of questions you can answer. And then I have to really emphasize on two things. AI. I know AI is getting popular. Everybody's pretty much using it every their daily life. I do too. But think about it. You guys are taking calculus 3. I'm pretty sure you're transferring to engineering major or a STEM field. You guys really need to know how to solve the problem and by building your critical thinking, right? I know like AI, ChatGPT, Gemini, whatever, they can give you answer in a short time, but I'm really asking you, can you do it yourself, right? So once you really transfer to for your college or university major, you guys there's no like online courses pretty much. There are
이거
a lot of
多少？
can I
120로.
mute yourself? Yes. There will be a lot of in person, and you're gonna work with other people by showing your capability and skills and your ability. So I'm helping you guys to build up your critical thinking by teaching this calculus 3 concept, but I really want you guys to do your work independently, okay? Not relying on any other AI stuff. Okay, you can ask some question, but please don't use it for other exams or assignment. Please try to your best first, okay? So please read through this AI use policy and students agreement. So if you go there, I briefly mentioned about like what is the purpose of this page, zero AI assessment, and da 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 da. And then if you agree, please click and submit it. Okay. So please read this page carefully. Okay. And then synchronous is going to be very, very important for you guys. It's not official yet, but many CSU and UC are talking about they're not going to accept asynchronous math or other courses for next couple semesters soon. So they're gonna ask you to submit your syllabus if you want to transfer to your to specific major. So that's why I'm talking about this AI and lockdown browser on my syllabus. Okay, so that I can protect you. You can safely move on to four-year university. Okay. All right. So that is something I really emphasize on AI. And also lockdown. Respondents to lockdown browser agreement. I'm pretty sure some of you guys have experience using this lockdown browser. Some high school are using this. And then I noticed that many students already know how to install and download it. So basically what this is, um, for test, only exam, we have a lot of homework, we have a lot of assignment. I don't have a lockdown browser for homework, okay? But for exams, I have to, okay? So for exam, there will be a lockdown browser, which means you're not gonna be able to open other tab like this, okay? So when you're taking the exam, only one, test page will be shown on your screen. So that's how we can make sure that you're taking your exam by yourself. Okay. So please read this one. This is very important page. I'm gonna show you quickly. Let's go to a module one more time for those who just to join. So I'm gonna just show you as a student view. So like you guys, once you agree for AI policy and lockdown browser, and then the next page is a sample test page. So click this. I really want to make sure you know how to install the lockdown browser. So take the quiz. Okay. So the passcode is A1B2C2. So type it. You can do it right now with me. Submit it. Okay. And then the next page, you can see download Respondus lockdown browser. Click and just download it and install through your computer. Just I want to make sure this lockdown browser does not work for cell phone or Chromebook. It only works for Windows, computer, laptop, or Apple Mac, those are two, computer or laptop, not tablet, not cell phone. So you have to use your computer. If you don't have a computer, if you come to our learning center, there are tons of nice new computer, okay, desktop. So you can come and take the test over there. But I want to really make sure this is online class. So please have your own laptop or computer at your home so that you can have all access to our Canvas shell and assignment and everything. So again, if you go to this page, simple lockdown browser page, click download, and then you're going to simply download it and install it. And then once you get it, something like the program will be installed on your desktop, and click it, and you have to re-log into Peralta student portal. So from there, you can go to Canvas and take the test. Does it make sense, you guys? Have you ever tried? Have you ever used a lockdown browser? How many people use a lockdown browser? Can you show me your hands up or something like that? Is it something new? We have 26 students. Oh, I have a couple students. So if you don't know how to do it, no worries. I can show you how to do it after I stop recording at the end. But try first. Go to module. Okay, go to module. Here, once you agree with AI policy and lockdown browser for this class, then go to sample test page and then take the quiz and then download it. Because I already typed my passcode. The passcode is already shown, so that download it. It's gonna be look like this and install it through your computer. Okay, so that's it. There's no complicated thing going. Just download and install it. That's it. Okay, so those are two things I really want to emphasize for this class. Okay, so let me go back to module. Yeah, so once you check those information, and then we're going to begin chapter 1. Like we have every week discussion. It's a chapter discussion. Okay, I will talk about it through the syllabus. So from discussion, I ask you guys to post 3 things. Okay, you could be asking question, or you can replying to other students. Okay, so there are 3 posting are required for your participating points. Okay, so this is you can continue to do throughout chapter 1, not every week, just chapter 1. You're gonna post 3 things, and then this is our embedded textbook. So there's no external link you need to go. Everything is here on our Canvas shell. So this is our textbook. My lecture is going to be based on this OpenStack textbook. Okay. So we're going to go over all the questions here later together, and then go to click next. Again, I post our PowerPoint, and oops, sorry, I need to get rid of this paper. But anyway, there's YouTube video also you can watch, but I'm going to give you guys a live session as well. And there are other external videos you can watch. Okay. And then there is a homework if you go to the next. Okay, so there's a quiz. Usually there is a less than 10 questions you can submit. Okay, so that's the, I'm gonna go back, module. So this is our 1.1, same thing, 1.2, 1.3, chapter 1. Okay, and every chapter at the end, we have a chapter 1 summary quiz. That's how I call chapter 1 checkpoint. So this covers entire chapter 1.1 through 1.4 concepts, okay? And then there's a chapter 1 video wrap up. This is another participation points. It looks like a lot, but actually not. You're gonna choose one of the questions that you feel it's challenging, and then you're gonna record it yourself, less than 5 minutes video, okay? So there's an instruction. I will talk about it when you, as the date close to the chapter 1 video wrap up. So check it out, okay? So I'm gonna go back to module. So that's how I create structure for chapter 1. Same thing, chapter 2, discussion board, 2.1, lecture video, homework, 2.2, at the end, yes, summary quiz, and we have a wrap-up video. So like this, we have chapter 1, 2, 3, 4, 5, a little bit of 6. You see that? It's a lot. Okay, So we're gonna work together, and there is a final project. So I will talk about this later, but you're gonna choose one topic that are related to, any topic in calculus, and then you're gonna write some paper. It's not a, difficult question. There is a detailed information. I will talk about it soon. So let's go to syllabus. I know you wanna really see how the, grading category weight works. So here we go. So I briefly show you the module. We have a discussion and project. This is your participation points. That's 20% out of total. So 20% means include discussion, wrap up video, and final project. So you have 3 things to do to get your participation points. Sounds good? So as you see, discussion, you can ask or respond to other students, wrap up video for each chapter, and final project is a final project, some essay. You're gonna choose the topic from calculus. And then reading and quiz, this is a weekly assignment. And then we have a chapter 1, 2, 3, 4. I'm trying to give you guys a lot of flexibility for this class. So I do have a weekly due date. So if I have a 1.1 today lecture, you have to submit 1.1 quiz by next Monday, which is January 26th. However, you can miss the due date. You're not gonna have any penalty because I'm giving you the fixed due date, March 2nd. So as long as you submit the quizzes and assignment in chapter 1 and 2 by March 2nd, you will still get the points. Sounds amazing, isn't it? So I try to give you guys a lot of time to wrap up and study, by spending your effort and time. Same thing, chapter 3 and 4, you can submit it as long as April 13th, you will get the points. Okay, so please make sure, even though I give you a lot of time, there are some students who do not submit the work by the due date. I'm sorry, okay? I'm not gonna give you guys any point after March 2nd or April 13th for each chapter 1, 2, 3, 4, and 5, 6, okay? So this is online class, which means you have already a lot of flexibility and time while you're managing a lot of things. So please do the work on time, okay? And checkpoint, same thing, the summary quiz, you have a same due date for chapter 1 and 2. And test, here we go, okay? You have 2 tests. I'm not gonna give you guys just 1 midterm. I'm giving you 2 tests, 1 and 2, because we have a lot of chapters. I don't wanna give you guys too much pressure. So once we finish chapter 1 and 2, which is the due date is March 2nd, we're gonna take the first test on March 2nd, okay? So the test page will be published on March 2nd from 6 to the midnight. You can take it any place, in your home or library or learning center, as long as you have Wi-Fi with your laptop or computer, because you have to use a lockdown browser. Okay, please make sure there should no conflict schedule with you. So I already announced it. We have a first test on March 2nd. It will cover chapter 1 and 2. The second test to date is April 13, covering chapter 3 and 4. And then same structure, we are using the lockdown browser. I'm pretty sure you're gonna be fine. Okay, so the final date, here we go, May 19, 1 day from 6 to the midnight, same structure, lockdown browser. Okay, so those are 3 days, I already announced it. And then please, arrange your schedule accordingly. Okay. Okay, I think that's pretty much what you guys are gonna do over the semester. Anybody has a question at this moment? I think I talk too fast or I talk a lot. Anybody has a question? Are you guys okay with this grading policy and everything so far? Can you guys just show me a beautiful thumbs up? Kathy, do you have a question? Oh, that's thumbs up. Gotcha. All right, sounds good, everybody. I see you guys a thumbs up. Okay, sounds great. Plus, I'm going to do my best to give you guys extra credits. So there are 4 different learning centers throughout our PCCD colleges, Laney, BCC, Alameda, Mary. We are running, they're running their own learning center. So if you go to there or they have an online tutor, you can find out. And if you work with them, more than 5 hours, I can give you extra credit as your effort. However, you have to submit. They're gonna ask you your login and logout time. So you have to keep track those hours and submit that information at the end of semester. Usually they can keep track of your visiting hours. Okay. So whenever you visit, ask and log in and log out. Please do so they can give that information to me at the end of semester. Okay. And one more thing, extra credit. So this work, right? Every week you're gonna with me Tuesday, Thursday, 4 to 6, and you are going to do the assignment. That's approximately 6 hours, 5 to 6 hours you need to spend per week, right? It's a lot of topics. So 17 week times 1 or 2 hours. This is your working hours, right? This is working hour with me in calculus 3. If you spend more than 110 hours, this is also considered as extra, okay? Because as an instructor, I can keep track of your hours through Canvas. They're gonna show me your visiting time, like logging out time. They can show me so that I can see how students are studying, engaging with other students. So yeah, keep on doing your work. All right, that's what it is. And then Learning Center, I talked about it. And then student accessibility, if you have any need or accommodation, please reach out to them. They're gonna provide some extra resources. Academic integrity and dishonesty. So I just wanna tell you one more thing, actually a lot of things. For weekly assignment, most of questions will be multiple choices and there will be a writing question. For those writing question, you must use your handwriting, okay? Or math editor that are embedded in Canvas. There's no copy and paste. Okay, I can easily see who really do their own work or not. If I see that, unfortunately, you will get F, okay? That's like very strong policy for this semester, for entire parallel time, okay? So please make sure every work should be completed by yourself, okay? Please do not rely on others or extra link. No, okay, I don't want to talk about this too much, but you guys already know as a college student, this is a college and we have a lockdown browser, even though you have a lot of question about that, but this is very important for now, okay? Every 4-year university, they're asking us to submit the syllabus because they want to see how we actually conduct the final and midterm things. So this is how I monitor your test and everything, so please do so. No rely on other external link, okay? So think about it. You guys are going to other university or you're gonna get a job in the future. They're gonna know how you're gonna solve the problem anyway, right? So I'm trying to help you guys to build up your critical thinking. This is your time. This is your time to learn and grow by building your thinking skills and critical thinking and every analytical skills. So yes, so please do your work. Merit library information is right there. But again, like we don't have any physical textbook. So everything is embedded. So there are further information you can take a look at. Okay. So that's my brief information about the syllabus. I want you really to read this carefully one more time. Okay. And then go to module. Please submit the quiz if you agree with the AI policy we created and lockdown browser. Okay. So that's something you need to do with meet and greet by next week. And let's go to 1.1 parametric equation. I'm going to hold up here. Anybody has a question about syllabus? So the good news is, even though I'm giving you guys a synchronous lecture for test, okay, it's happening every Monday. So March 2nd, April 13, and May 19, those are Monday. So please, arrange your schedule accordingly so that you don't have any conflict schedule, okay, while you're taking those tests and final, okay? All right, so I'm gonna stop sharing. I think there are a couple of comments. Let me go to the chat. Are the recorded link posted to Canvas after lecture? Yes, I'm going to post this lecture right after our live session. Okay, short clarification. Do MCQs also require you write? No, for the multiple question, I don't require for the writing. There are specific questions you need to submit your work. So if you go to Canvas later quiz, there are some writing questions. So please upload your file for those particular questions, not every question. But for test 1 to final, you will submit your own work for each question. Test is a test. Yep. Okay, we need to submit photo evidence. Yes, for test. Yes, I will explain more when we get there. For test 1 into final, I will talk about those instructions as we get to the date closely. Are we able to take a picture for our work and then edit? Yeah, you could do that for writing portion for weekly assignment. There should be an upload button if you, okay, I think that's somebody helping how to do it. So I think I'm gonna show you that quickly. So let's say, I don't know which one has a 1.3. Let's see, let's go to 1.4 quiz. I hope there's a writing portion. Hopefully, if not, okay, here we go. So this is the question that I asked you to upload your file. So once you read the question, you're gonna work on this problem on your paper, right? And then here we go. Click insert, click image, upload image, okay? The one thing I wanna give you, very good information, you can download Canvas app through your cell phone. So once you take a photo, you can automatically use the cell phone Canvas app and you can submit it through there as well. Okay, so there are multiple ways you can submit the image. So here, insert image, upload image. Okay, so this is how you're gonna submit the writing work. So for test and final, look like this. Okay, there will be less multiple choice questions. Yeah, I'm not gonna give you guys too much anxiety, but I will give you a lot of time at the same time. Okay, so no pressure, no anxiety, should be okay. Okay, you guys gonna be really, really fine. So I think that was the question. I'm keep reading it. For the test, will we join the Zoom on Monday? Nope, you're not gonna join. You're not joining because you're gonna use lockdown browser and take it anytime between 6 a.m. to the midnight in any place you feel comfortable. Okay. So we are meeting again after the test, Tuesday, Thursday live session. So during the live session, I'm giving you the lecture. All right, anybody has a question? Is it clear? Okay, so I'm gonna give you guys 1 minute break. I'm gonna set up my lecture. And if you're ready, please download our lecture note through your tablet or any other electronic devices. You can print it out. Let's begin 1.1, okay? So let me go to 1.1 lecture notes. Okay, let me join 1 second. Just 30 seconds, I'm gonna join. I'm gonna stop sharing. Did I stop sharing? No. Okay. All right. Recording in progress. Can you hear me? Can you hear me?
Yeah.
Yeah.
Thank you. All right. So I'm going to share my lecture note finally. Okay. All right. So this is 1.1. So we talked about syllabus and Canvas shell. I don't know. I want to see my face. I see Edison on your. Okay, let me change something. If I can show my face, how to do that? One more. Let me just stop sharing. Okay. Yeah, now it's me.
Gonna reshare. How about now? Yes. There we go. All right, so let's begin our work. Okay. So 1.1 parametric equation. Sorry again, somebody asked me the question, the math editor only. Does this math editor box only apply to set question? Yes. So math editor, it's gonna be embedded in your writing question. So sorry about that. I'm gonna share one more thing because somebody asked me about the math editor. So if you go to, I think 1.4, we do have a writing question. Oops, sorry. Okay. If you go to 1.4, but for writing portion, you have to use a handwriting only. So math editor actually does not really need it, but I will show you. So preview. So if you want to use the math editor, here we go. There's a math editor. Click, I'm gonna make it bigger. So there is a math editor. This is a math editor. You can type anything, fraction, exponent, radical, everything. So you could use math editor as well. But for writing question, I'm gonna make a specifically mentioning, please use your handwriting and upload the image. So yeah, that's what it is. Okay, I'm gonna stop sharing. Go back to our lecture. I think I think no more question at this point, so I'm gonna go back to our lecture notes. Okay. All right, thank you everyone. Okay, so here we're gonna begin 1.1 parametric equation. Okay, so let's see. So parametric equation was part of a chapter in calculus 2, if you remember, right? So we're gonna go back to parametric equation one more time because this is chapter 1 in calculus 3. So let's go to parametric equation. So let me go to here. Okay. Are you guys ready? Okay. Okay, so I'm gonna talk about, so 1.1, we're gonna talk about parametric equation definition. And then I'm gonna talk about the basic curves such as a line and circle later, how that is related to parametric equations. And then we're gonna briefly talk about the cycloids later. Okay, parametric equation. So what is a parametric equation? Okay, as I mentioned, there's a definition, but normally, think about it. I'm gonna write the pen here. So normally, in algebra, if you took pre-calculus, calculus 1, other math courses, we describe a curve or line using one equation such as y equal to f of x. So in this function, if you have an input x, you will get output y, right? So you have just two parameter, x and y, input and output. But here in parametric equation, you have like three kind of variable, x, y, and t, okay? So in parametric equation, both x and y, they have a third variable t. So x function is gonna be like you have another input t and you will get the output x. Even though the x, y, we have a two function, there are sub variables such as a t. So this is how we're gonna call parametric equation. It sounds like a little bit weird, so I'm gonna show you the example. So let me see the example quickly. I'm gonna just go back to here. So we are not gonna just use a simple y equal to f of x. We're gonna have some function here. We have x-axis and y-axis. You will have x will be the output by, sorry, my eraser. The x will be t1 and y will be t1. So when you have those 2 points, this is going to be c1. Okay, so x and y, this is a function, but it's also has another parameter t. Again, c2, x, t2, y, t2. It's continuing ci equal to x, ti, comma, y, ti. So this is a little bit different, simply x1, y1, x2, y2 from the regular, regular linear function or other quadratic function. This is more complicated, right? So what I'm doing here, you can still make a curve or a graph by using this parametric equation, okay? So this is very abstract so far. I will show you the detailed example. So I'm going to just highlight the definition here. A set of a point x and y obtained as t varies over the interval. We call this, this should be t is called the graph of the parametric equation or parametric curve or plane curve. These are all the same language, okay? Parametric equation, parametric curve, or plane curve, they're all indicating the same curve, okay? So I'm gonna go to the example here, okay? By using this abstract concept, let's really look into the numbers, how it works. So I'm gonna use this example. I have a parametric equation like this. X function, x of t, equal to t minus 2, and y function has a 2t minus 1. So I'm going to create a table. Maybe you can create a table with me. And then we have x t equal to t minus 2. I have a y t equal to 2t minus 1. Are you guys okay? And now I'm going to just choose a random number, like some simple t equal to 1, 0, 1, 2, 3, 4. Okay? And let's evaluate each x and y output. So if you plug in 0, 0 minus 2 is a negative 2. And then for y function, if you plug in 0, it's going to be negative 1. If you plug in 1, keep on doing it. 1 minus 2 is a negative 1. And 2 times 1 is 2 minus 1 is 1. So keep filling out the rest of information. If I have a t equal to 2, this is a 0, this is a 3. If I have a 3, 1, 5, right? And then 4 give you 2, and then it's going to be 7. Oh my goodness, what am I doing here? And now we can actually draw the graph. Let's draw the graph. I have x and y axis. We are going to say t equal to 0. So what is a t equal to 0? T equal to 0 means your x coordinate is a negative 2, y coordinate is a negative 1, right? So where is a negative 2, negative 1? This is t equal to 0, negative 2, comma, negative 1. This is a t equal to 0. Are you guys okay with that? Okay. And then what about t equal to 1? T equal to 1 is a negative 1 and 1 here. T equal to 1. Keep on doing. Where's a t equal to 2? 0, 1, 2, 3. This is a t equal to 2. 1, 5 right here. T equal to 3. 2, 7. T equal to 4. So this line, if you draw, It looks like a linear. It should be linear. Oh, sorry about that. Are you guys okay? Yeah. So this line we call parametric equation or parametric curve or parametric plane. Okay? Okay. My Zoom is okay because I'm a little frozen. Are you guys okay? Okay, we good. So in this case, this parametric equation gives you something like y equal to mx plus b form. But not all the time. It could be parametric, it could be exponential, it could give you any different function. But we call this is a parametric equation. Okay? Okay, let's take a look at one more example, letter B. I'm gonna make a new paper, new page, add page. So here. So let's take a look at B one more time. Okay, here. I have a two function x and y. Let's keep building the chart. I have a t and I have xt, 3t plus 2, and I have a yt equal to t squared minus 1. Okay, what number are we going to do? We can begin 0. I can start -3, -1, 0, 1, 2. Just I'm choosing some random number because it looks like simple. So if you plug in -3, what are you going to get? -9 plus 2, -7. And this is going to be 8. Am I correct? So what does it mean here? T equal to -3, specifically it has a -7, 8. But we are not using -7, 8 on the chart. Just say it's t equal to -3. Because we have a 3 parameter, x, y, and t. And then keep on calculating, -2. -2 times 3, -4. 4 minus 1, 3. -1, -3, -1. It should be 0. Please check my work. Am I correct? Okay, if I have a 0, okay, this is going to be 2. This is going to be -1. Keep on going. If I have a 1, 5, and 0. Ooh, if I have a 2, it's going to be 8. It's going to be 3. So let's draw the line one more time. So let's graph. Where is a t equal to -3? It's going to be 1, 2, 3, 4, 5, 6, 7. And all the way up, 1, 2, 3, 4, 5, 6, 7, 8. So this is t equal to -3. Keep drawing. Let's see what kind of curve you're going to see. Where's the t equal to -2? -4 and 3 here. This is a t equal to 2, which is -4, 3. T comma equal to -1 right here. T comma to 0, 2 comma -1 here. T equal to 1, 1, 2, 3, 4, 5 here. T comma to 2, 6, 8, 7, 8, 3. So this is a t equal to 2. Dun, 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 dun. What happened? This is not linear. This is a curve. This is a parametric equation. So again, we call this is parametric equation, but in this time you have quadratic equation specifically because it is not a line. This is a curved line, right? So what I'm saying is parametric equation, it could be linear, it could be quadratic. We're using 3 different parameters in this time. So this is a parametric equation because it can be any different type of function. Okay? So this is very traditional way to find out the parametric equation, but I'm still didn't mention how to calculate what is this equation exactly, right? We found out in the example A, it's going to be linear, but I didn't calculate it y equal to what? We just know y equal to mx plus b form. Same thing, B, we found out the curved line, the graph, it's a quadratic equation, but I didn't find out exactly what it is, right? So let's take a look at it more and more, okay? So just think about the concept, what the parametric equation look like. We're gonna go to, and then I'm gonna skip this one for now. I'm gonna go down a little bit. Let's really find out the parametric equation. Are you excited? Yeah, so here are a couple methods to find out the parametric equation, okay? So one method is eliminating the parameter because 3 parameter looks too much work. So I'm gonna show you the one method. So we have the same example, let's say A. I have a 2 function x and y, and they have a 3 parameter x, y, t. Okay, there are too many parameters. I just want to know what the function look like when you really graph it. So here we go. First, x of t, 3 minus t. This is the function. Just consider this is like x equal to 3 minus t. Okay, I'm not going to use like small parentheses, just x equal 3 minus t. And then you're going to solve for t. If you solve for t, what happened? T equal to, what happened? 3 minus x. Am I correct? I just solve for t minus, solve for t. And then t equal to 3 minus x. Are you guys okay with that? Now, we're going to sub this into the second function y. Then what happened? This function will be y equal to times 3 minus x minus 3. So you guys know the basic algebra. 6 minus 2x minus 3, y equal to negative 2x plus 3. So what happened? These two functions we just have, they have a parametric equation, which is a linear form, and y equal to negative 2x plus 3. Or you feel like, maybe you feel like, it's really true? Let's check with the graph. So I'm gonna make the chart. Gonna make this a little bit smaller. So let's really check it out, guys. We have t, and then I have x function, 3 minus t. And I have a y function, 2t. Let's choose a random number, negative 2, negative 1, 0, 1, 2, 3. Let's plugging in. Okay? If you're plugging in negative 2, it's going to be 3 minus minus, positive 5. And then y will be negative 7. If you plug in negative 1, it's going to be 4 and negative 2. Actually, negative, what happened? Am I correct? 2t minus 3. 3 minus, okay, that's fine. Wait. Negative 2 times negative 5, negative 2. I think I made a mistake here, right? You know what? I forgot negative 3. Sorry about that, guys. Right? This one has 2t minus 3. So I have to write 2t minus 3. Thank you. So now this one will be 10 minus 3, 7. Negative 2, the minus 4, minus 7. Sorry, am I right? Yes, okay. Then what happens? 0, it's a 3. It's going to be negative 3. 1, 2, and 2 times 1, 2 minus 3, minus 1. 2, it's going to be 1. It's going to be 4, 1. And then 3, 3, 0, and 3. All right, we fill out the table. And let's graph. So if you graph this one, what happened? Where is a t equal to -2? 5,7. It's actually all the way down. This is a t equal to -2. 4, -2 is here. 4, -2 here. T equal to -1. And 0, 3, -3. My graph is not really perfect, but it should be a little bit linear. So let me graph correctly. So we have like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yes.
I think for the t at -1, it should be -5 for the y.
Yes, you're right. This one. Thank you for checking. It should be -5. Yeah. And then we have a 4, -5 right here. This is t, -1, 0, 3, and -3. T, 0, 2, -1. Sorry, my graph is too tiny. But t, 1. And then t, 2, t equal to 3. So it looks like actually linear. It's going to be like this. Actually, my graph is not really pointing out, but if you really draw the line with them, it's going to be linear. And what happened? This is y equal to mx plus b, which is a linear equation. And this is parametric equation, which is y equal to -2x plus 3. This is the equation. So we check by using this traditional way, because if you really find out the linear equation, there is a 2 point, you're going to choose a random 2 points and then create the linear equation. It's going to be y equal to -2x plus 3, but it takes a long time, right? So what you can do, the elimination method, like this, substitution one way, and then automatically they're going to be matching. So the parametric equation we found out in this question is y equal to -2x plus 3, which is a linear equation. Yes. Are we okay? So parametric equation, you can actually find out what that is exactly. So one more example. So 1.1 is all about like parametric equation like this. Find out the parametric equation if you have those two information. Okay. So let's take a look at the next question. It should be B. Let's go to B. I want you to really try this one. So we have a two function. You can do this problem by creating the chart, but again, it takes a too long time. So let's use the method we just talked about, eliminating the parameter. So I'm going to consider. So we're going to find the parametric equation of the function is x of t, 3t plus 1, yt, t squared minus 4. So what are you guys going to do? As I mentioned, consider this equation like x equal to 3t plus 1 and solve for t. Yay. So what happened? X minus 1 equal to 3t. X minus 1 divided by 3, that's going to be t. Please substitute in here into the y function. So y will be x minus 1 over t, right? Square minus 4. So you're going to expand everything, please. X squared minus 2x plus 1 over 9 minus 4. And then if you write it beautifully, this is going to be 1 over 9, just same as x minus 1 squared minus 4. I just back and forth. Oh my God, what is this, guys? This is quadratic curve. So what happened is, even though you don't need to create this whole chart, you can find out this two function gonna create quadratic curve. The first one was a linear curve. Second is a quadratic curve by using the eliminating the parameter method. Okay, so when you really graph it, you guys know from pre-calculus or calculus 1, this is going to be parabola shape, right? Which means where the vertex is going to be from here. This is the parametric equation, 1 comma negative 4. And then since the slope is positive, it's going to be the downward shape. So when you graph it, it looks like 1 comma 1, 2, 3, 4, and then they're going to be upward because the slope is positive. So that's your parametric curve of this information. We don't need to create the whole chart, okay? So you can find out this beautiful parametric curve. It could be linear, it could be quadratic, depending on the question. Okay? I'm gonna hold up here. Are you guys okay? Can you guys show me your thumbs up if you're good to go? All right, everybody is happy. That's the most important thing. Everybody's happy. Okay, everybody's happy. You guys doing math in this beautiful evening. All right, let's keep on doing the next one. Letter C. Sometimes it might not linear quadrant. Let's check it out. The C. I'm gonna go down at page. So the C is right here. It's hard to see. I'm gonna write it here one more time. So the C, we have a same question. Find the parametric equation of, what was the function x of t? I'm looking at 4 minus t, and y has radical t, and t should be positive or equal to 0. Okay, can you find out when you really graph this function, how does it look like? Like what kind of curve you're going to find out? I'm not going to create the table because that's too traditional way. So let's use elimination method. So let's consider like x equal to 4 minus t. I'm going to solve for t, right? That's how we do it. So x minus 4 equal to negative t. So t will be 4 minus x. We're going to plug in here. There we go. Then what happened? Y equal to radical 4 minus x. Do you remember this function, the radical function? Yeah? If you graph it, that's the parametric curve of those two functions. So this is x cannot be, any number that is a less greater than 4 because it's going to be negative number. If you have a 5, it's going to be radical negative 1, which is not real number. So this is, if you graph it, they're going to passing through 4 comma 0. If you remember from pre-calculus a long time ago, it's going to be half circle like that. So this is a radical function. Do you remember that if you graph it? So these two functions give you radical curve. This is their parametric equation. This is the answer. And then it has a specifically radical curve. Yeah? That's the answer. Nothing is complicated. So I want to really emphasize on, think about the definition of the parametric equation. It looks like very abstract. If you go up all the page, it looks like x of t equal to whatever. It looks like a hard when you really understand the abstract thinking. But when you really graph it, it's not, okay? Parametric equation, it's the curve from 3 parameter like x, y function as an additional t variable. But how are you going to graph it actually, right? It's hard. You can do traditional way. One way is to create a chart and graph it, but that takes a long time. So second way, I'm just using the eliminating method. Just solve it like x, y substitution, and then they're going to naturally find out the parametric equation. It could be linear, quadratic, or any other function format. Okay? All right, we good to go. I'm going to go down the next. We're going to keep building this idea. Oh, what's going on here? So far, to find parametric equation PE, you can use a table, very traditional graph and chart method. It takes a long time. So I'm not going to do this way anymore. I'm using shortcut. And this is how you can code later. If you're using computer science, knowledge, we're using shortcut idea. So substitution method, we just talked about it. Substitution, eliminating. And second one is some mathematical idea. This is example 2. We talked about it above. And then mathematical idea, we are using this one. This is very unique method. So let's look at it. Same question. They want you to find out the parametric equation, but in this time, this is not number anymore. This is a trigonometric function. Oops, I'm sorry. This is a trigonometric function. When you graph this, like there's X, there's a Y, there's a T, how would you be able to graph it, right? That sounds like, Professor Ben, I don't know what's gonna be happening. You can do it. Okay. Trigonometry identity. One concept, if you remember, sine square x plus cosine square x equal to 1. Do you remember this? This is always true all the time. This is one of the trigonometry identity, right? Or you can call Cartesian equation, like x squared plus y squared equal to 1, or r squared. So hold up here. We're going to use the trigonometry identity. So let's look at this. Because there's no way, I'm not going to solve like x equal to 2 cosine t. I'm not going to solve for t. It's going to be more complicated, right? So by using this method, sine x squared plus cosine squared x equal to 1, this is always true as one of the trigonometry identity. Let's do the same work. So here, we have x equal to 2 cosine t. We have a y equal to 2 sine t. Let's multiply double. What is x squared, guys? That would be 2 cosine t entire square. So that's going to be 4 cosine square t. Are we okay? And then y square, same thing, 2 sine t entire square. So y square will be 4 sine square t. Am I okay? Now you're going to adding them up because x square, y square, 4 cosine square t plus 4 sine square t. Da-da-da-da. Combining like term. 4 cosine square t plus sine square t. Are you okay? What happened? We just talked about it. This guy is what? Uno. Number 1. So we found out this is going to be 4. Make it a little bit smaller. So we gotcha. This is x squared plus y squared. 4 times 1 is a 4. So what happened? We got it. This is your parametric equation. There's no more t, just x and y. Oops. This is circle equation. And then we can find out the specific points. The where 0, 0, that's your center with the radius equal to 2. That's what the x squared plus y squared equal to 4 means. Do you remember? So these two ugly, x equal to 2 cosine t, y equal to 2 sine t. When you find out the curve of those two functions, they're going to create a beautiful circle function where 0, 2, 0, 0, radius equal to 2. That's a circle function. x squared y squared equal to 4. That's the answer. In this case, we found out the circle function, not linear, not parabola, not radical. So you see that parametric equation can give you many different type of function as an answer. That's why parametric equation is very unique. So here, I use a very useful mathematical idea, specifically trigonometric identity. All right, everybody okay? Gotcha.
So
Yes.
4 would be the diameter?
Yeah, because circle function means x squared plus y squared, r squared. R is a radius. R squared is actually diameter. R itself is a radius. So we have a 4, that's a 2 square, so radius equal to 2. So in this case, x squared plus y squared. If you have x, the circle square can be transformed. More specifically, a comma b, this is the center. R is the radius. Are you okay? Yeah. So that's why. So if you forgot the circle equation, just take a look at it. Just take a look at your old notebook or Google search what the circle equation look like. So you will see a lot of form. Basically, this is the original, like where 0, 0 center. This is where a comma b. You can have like x minus, let's say 8 square plus y minus 3 square, let's say 9. What does it mean? The center is 8 comma 3 and then radius is a 3. So when you graph it, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This is gonna be the center, 8 comma 3, and radius is a 3. 1, 2, 3, up 1, 2, 3, 1, 2, 3, 1, 2, 3. So this is gonna be the circle of this function. So check it out, the circle equation. But what I'm saying is, in this question, we found out the parametric equation as a circle function. Okay? So here, I use some mathematical idea, which is a trigonometric identity. You need to know this concept, right? From the trigonometry or calculus one, right? Okay, I'm gonna hold up here. Are you guys okay with that? Are you guys happy? Can you guys show me your thumbs up? If you guys are good to go, show me your thumbs up. Thumbs up. All right, beautiful. All right, just 2 more questions, guys. Hang in there. I'm not gonna give you guys like too much information today. I know it's the first day, right? So let's think about letter B. Letter B. Let it be. Okay. So again, Professor Ben, X function has a 3 sine t, Y function has a 2 cosine t. Sorry, my typo. It should be cosine t, okay? And then t is between 0 to pi, which is between 0 to 180 degrees. So anyway, if you want to graph it, yeah, you could try by creating the chart, but that's too much calculation. So think about it. Like what other mathematical idea you could use, because you're now card 3 level. So just think about it. One method we just talked about is this one. So here, Professor Ben, I'm going to keep on doing the same work because I know sine square x plus cosine square x equal to always 1. We know this fact. Let's just multiply, double. Okay, so xt, we have x equal to just 3 sine t. I'm going to x squared will be 9 sine square t. Same thing, y equal to 2 sine t. So y squared 4 sine square t. Everybody can do this. Now, Professor Ben, I know how to do it, but something, if I'm just adding up, it looks like x squared plus y squared. No, something we have to do. We have to eliminate 9 or 4 so that we can have solely, this one should be cosine. This one should be cosine, right? 2 cosine, 4 cosine square. So just divide it by 9 both of sides, x squared over 9. This is a sine square t. Y squared over 4, we got cosine square t. So now I have this one. sine square, cosine square. How about adding them? So what happened? Sine square t plus cosine square t, right? What is this? X squared over 9, y squared over 9. That should be equal to 1, correct? So if I write it again, that's what happened. We got this one. So your answer is pretty much, it looks like this. But what does it mean, right? This is ellipse shape. If you graph it, so it's a part of the circle function, but it's not going to be like a perfect circle because this means y squared 2 over 4. Oh yeah, sorry about that. Thank you, thank you. What am I have? Thank you, thank you. I have a little mistake here. This should be 4. So this one 4. Yes. So what does it mean? This one, this is your answer as a parametric equation, but we found out the ellipse, which means if you have a circle, one circle, this is radius, but one radius r equal to r1 radius equal to 9. My bad. 3, and another radius is a 2 because this is r squared, this is r squared. So where center 0, 0, because there's no a and b, x squared, y squared, that's it. So we have up 3, 2. So one radius is 3, another radius equal to 2. This is ellipse shape. So that's the ellipse equation, if you remember, right? So that's the answer. Okay. So in this function, when you try to create the curve, parametric curve, it shows us ellipse shape. Okay, that's the answer. So you see that? Wow, it's a lot. Linear, quadratic, radical, circle, now ellipse shape. So that's how you have 3 parameter works together when you graph it. It could be any shape. We call this as a parametric equation concept. Okay, almost there. One more example. I'm gonna hold up here. How do we tell? Yeah, you could do this way if you want. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2 if you want. Right? But it's the same. They are same though. If you turn around, it's gonna be the same shape. Turn around, it's gonna be the same shape. So it doesn't matter which area, which one is which. Because they're same shape. If you cut it, they're gonna be same matching. If you cut this shape, they're gonna be the same exactly. The area is gonna be the same. The center is gonna be the same. Okay? So somebody asked me, how do we tell which axis? So here, doesn't matter, same radius, the same shape has the same area. That's why. Does it make sense, Shechik Kumar? Yeah. Okay, so if we have a more dimension, it's gonna be complicated, but here it just doesn't matter. Think about you're gonna cut this paper, the shape is gonna be just same area. Yeah. X grab, suppose 3. Yeah, you could tell X could be 3, Y could be 2, but in this time it doesn't matter which one is a 3 or 2 because it's gonna be the same shape. That's what I'm saying. Okay. So think about it, ellipse shape. If you take more complicated, if you take advanced math course, there's a more deeper knowledge, like how we're gonna define like which one is which. But here, calculus 2, it doesn't really matter. Okay. Yeah, because we are not gonna really evaluate anything else. All right, everybody okay with that in letter A and B? I'm gonna go to one more mathematical idea, letter C. That's something I want to go. Can you guys just show me your thumbs up if we'll be good to go? Are we good to go? Yes. Okay, let's go. I know. I wanna give you guys. I want you guys to have a great dinner later. But let's hold here. Let's hold up here. One more. I'm gonna done almost. So let's go to C. So I think we have the same question. Letter C. I'm gonna change the color. C. So we have a 2 function. Xt is sine function. if I correct, yeah, sine, and y is cosecant function. I want to really find out the parametric or whatever the curve that they're gonna, when you graph those function, right? And then this one is between this. Okay. So here, you need to think about other mathematical idea. What other mathematical idea do I know? Do you remember the 6 trigonometry identity? Let's write all 3 or all 6. This trigonometry concept, if you remember, sine x is 1 over cosecant x. Do you guys remember those like a reciprocal idea? Cosine x, these are all your pre-knowledge. We have, so you see that math is accumulated idea. So think about it. These are, you learned trigonometry identity long time ago. So tangent is cotangent, 1 over cotangent x. And same thing, cosecant is 1 over sine x, right? So likewise, secant x is 1 over cosine x. They're all family, 6 family. Cotangent x is 1 over tangent x. Dun 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 dun. Do you remember this? Yes, I do. We're gonna use this one here. Yes. So here, let's continue. What happened? X function is a sine. So x equal to, I can consider x equal to sine x. And what happened? Y equal to cosecant t. Sorry, that should be t. Sine t. Like cosecant, like nobody are comfortable with cosecant, secant, cotangent. So I'm going to change it. This is the same as what? 1 over sine x. Right? So now what are you going to do? We know that x equal to sine x, substitute here. So this is equal to 1 over x. That's it. So we found out y equal to 1 over x. This is, if you graph it, this is odd function. So this is a parametric equation, your answer. If you grab this one, this is going to be looks like this curve. Parametric equation is y equal to 1 over x. Yes, Edison.
Yeah, so I have a question. What's the point of the bounds? Like t is greater than equal to negative pi over 2 and less than equal to pi over 2.
Yeah, this is this is sometimes the graph, it's gonna be like continuously going. So in this case, think about it. This is if you have negative pi over 2 and pi over 2, because t is here. If you have some number that is less than negative pi over 2, maybe it's hard to identify it because the function is to keep going and going and going and going. They're never going to touch this. So this is actually pi over 2. Am I right? This is 90 degree. So I believe this one, it's better. I'm going to just change this one. Sorry, 0. Let's say t is between 0 to pi over 2. What does it mean? Whatever the degree should be between 0 to 90 degree, right? So actually the perfect answer is going to be only this line. If I just change the question like this is the answer. So I just want to modify this question a little bit because a negative degree, it's a little bit not make sense in this question. So let's change like t is between 0 to pi over 2 so that we are only talking about the first quadrant. Am I correct? First quadrant. So when you find out the parametric equation, which is y equal to 1 over x, but you have to specifically mention it, it's only cover first quadrant because the t covers whatever the degree they're indicating is 0 to 90 degree, which is the first here. Okay, so that should be the final answer specifically. So this question, yeah, that's a good question. What does it mean, like inequality between 0 to pi over 2? So yeah, some question looks like tricky, but yeah, thank you for asking. Everybody okay with that? So I want to finalize it. Yes, we found out the parametric equation y equal to 1 over x, but specifically we are looking for the graph on the first quadrant because the degree should be between 0 to 90. Okay, so I'm going to hold up here. So I'm going to hold up. So we so far talk about the parametric equation. Almost done. Okay. It's very good question to think about it. Okay. If you have a three variable or parameter, how are you going to graph it? Like that's something our out of mind in calculus 1 and 2 level, but now you have to think about 3 or 4 and 5 variables. Okay. All right. I'm going to continue this question. So question 4, I'm going to skip this one. Try yourself. The same thing. What other mathematical idea you need to think about it? So I see cosine and sine. Maybe you can think about cosine square x plus sine square. You can think about this idea and apply it to find out the parametric equation. Try. Okay? All right, I'm going to do one more last concept, parameterizing curve. I'm going to go down slowly. This example 4, I'm going to skip it. You can try. I think this is a very similar question we did above the one of the questions. All right, what is a parameterizing curve? So now, this is very interesting. I have a question for you. What if we would like to start with the equation of curve first, and then I'm asking you, can you determine a pair of parametric equations for that curve? What? Yeah. So far, we have two functions given and you found out the curve we call parametric equation or parametric curve. Now, I'm asking you, we are doing the backward. I'm going to give you parametric equation or curve first, and I want you guys to find out what two possible functions were there before, right? You're looking for the backward in this time. Okay? So we call this process parameterization to find out the two xy function. We call this process is a parameterizing, okay, to find out the given function. So here's example. I have example. Find the two different pair of parametric equation to represent the graph of this. So somebody found out this linear equation y equal 3x minus 5 from the given x, y, including the t variable. Yeah? So whatever the example here from our embedded textbook, so you can take a look at textbook later, but let's think about it. So here, I'm going to just use a very traditional way, two questions. How would you be able to find out the two given function? So we have a y equal to 3x minus 5. This is a parametric equation as a linear function. Linear equation or linear function. So first step, we're going to choose a random function in this time. What I mean by that, we have a complete freedom in the choice for the two function. I'm going to write it. This is something like weird, but that's something true. We have freedom in the choice for choosing two xt yt function. Something we have assumption. Okay, so let me try here. Let's say I do have x equal to t. I have x t function is a t. And then I have a y t function is a 3t minus 5. I don't know whether it's true or not. This two function going to give you this parametric equation. I don't know, but let's try. We know how to do it. So x equal to t, when you solve for t, t equal to just x. I'm going to plugging in here. So y equal to 3. If you're plugging in t equal to x, x minus 5. Oh, that's linear. So this is one way you can find out the parametric equations for this linear. So in this case, these two functions are one of the answer. There are many, many answers you can think about. I'm going to show you one more. When you find the equation, do you also have a define it? Yes, we can think about the definite bound, but here just to leave it for a second, because we are not going to specify the range of t. Just definite from negative infinity to positive infinity, because it's a linear. Okay, that's fine. Yeah. Thank you. Yeah, thank you. But for like specific question, I will create an interval, but just leave it for now, okay? Like every number possible here. Okay, so other possible function can you find out? What other function can we find out? Professor Ben, I'm just gonna say let maybe xt. How about 2t? And y equal just same. 3t minus 5. How about that? I don't know. Let's try. Let's try. We could try this. So let's do it. X equal to 2t. Am I right? And then now you're going to solve for t, x over 2. Plugging in here. Y, t, or get rid of just t. Y equal to 3 times x over 2 minus 5. Y equal to, am I correct? If I have 2t, what happened? It's going to be 3x over 2 minus 5. I don't think this is really true. But let's think about it. What other number can work? X equal to 2t, y equal to 3x minus 5. Did I create correct one? Sorry. Yes. So maybe it's hard to find out, right? What do you guys think here? Are we okay with that or not? Mm-hmm. 16 minus 5. Did I make a mistake here? T, x equal to 2t. T is x over 2. I'm just going to look at somebody. We can do y equal to 6t. Okay, let's see. I'm going to change this one. 6t minus 5. Okay, so 6t is x over 2 minus 5. Yes, y equal to 3x minus 5. Same answer. So you see that? This two function also going to give you y equal to 3x minus 5 parametric equation. So what I'm saying here, there are many possible pairs of x and y function, xt function, yt function, to get the same parametric equation. What does it mean, right? Even though they have a different x and y, they have a same curve, right? Same PE. Maybe they have a different speed over time. That's what they mean. So think about it. This is a little bit abstract, but I'm going to explain one more time. Do you remember like y equal to x, y equal to 2x? If you just look at the simple function, they have the same linear. Y equal to x is going to look like passing through this. And y equal to 2x is passing through, but a little slippery, because they have a more speed. They have the same linear function, but they have a different speed, but it has the same path. That's what I mean. Okay, so just think about it. This is not really like super important concept in 1.1. Just I want to give you the idea. To get the same parametric equation, there are many possibility of x and y function, as you see here, right? You can choose these two combination, but you get the same. You get y equal to 3x minus 5. I choose a totally different function too, but you get the same parametric equation, right? So they have the same curve shape, they have the same path, maybe it's a different speed. That's what they mean. So somebody asked me, so on the test, ooh, we already talked about the test. Okay. Will we be able to choose which equation will be? Yeah. So there will be if I have this one for test, maybe I will specifically mention like find out 2 or 3 answer. But yeah, you can try and test it. Okay, that's the one way you could find out the answer. Yep. All right, sounds good. Okay, almost done, guys. I'm really almost done. Hang in there, just 10 more minutes. So this one is also same type of question. We can talk about it like parameterization of a curve. So this is already parametric PE, parametric equation. They want you to find out what the x and y. So you can think about a lot of possibility, right? So I'm gonna skip this one because now you can think about the same strategy we did here. Try this. Okay? Try this and find out as many as you can. There are many possibilities, right? And also, this is from our OpenStack textbook example. There's an answer. You can check. Okay? So I want you guys to really try and think. Okay? Maybe this one could be in the exam, right? So usually the question that I skip could be in the exam. That's the pattern that I have. So I want you to really try, right? Because I already showed you the example. Now it's your turn. Okay, the last concept here, this is not going to be on the exam because this is just a small concept in calculus. But here, this is very interesting. Cycloid, okay? What that mean is my color here better. So if you have this two type of function, like we have x and y, it looks very ugly. X of t has 8 times t minus sine t, y of t equal to 8 times. If you have two this function, and they have a very interesting parametric curve. We call the shape of the parametric equation of these two pair cycloid shape. So I'm gonna just give you guys the website. Let's see if I can work this. Oh, this is not work anymore. Okay, I used to have this website. Let me see. Yep, I'm gonna share this. Can you guys go to this? Everybody just click. I share in the chat. www.geogebra.org. So you can create this equation x of t times a. You can choose any random number, like a could be 2, sine t, you can choose any random number and then graph it. Our goal is to see the graph, right? Those are 3 parameters. And then they're gonna create very interesting shape. There keeps circling, like first they're gonna keep circling by using the radius. And then it's a repeating. And that shape we call cycloid. But we are not going to talk about in detail here. But check it out with the graph here. I already shared with that. So I'm going to share the graph here. I'm going to stop sharing. Can you guys see this is GeoGebra? I'm going to go to, where is it? Okay. I'm going to share that graph. Oh, I cannot share because okay, let me go if I can share here. But anyway, I'm gonna share with the computer. Okay, can you guys see this? So this is a cycloid. That's what we call cycloid animation. So if you go back my PowerPoint, whoa, those X and Y function look so complicated, but actually you can graph it. That's the idea. And this cycloid is part of, we call parametric equation. It's a part of the parametric equation as well. And then as if you change like A or whatever the number, it could be wider, it could be, smaller. That's the graph. So the way they're working is so beautiful. But we are not going to calculate or evaluate for this one. I just want you to share, parametric equation is a huge concept. It's so broad. And you can have a lot of different type of shape by choosing two X and Y function, including T parameter. Okay. So I'm going to go back to just two more slides. I'm going to stop sharing, share. Okay. Sorry, it's a little slow. Okay. Gonna go back. Share. Stop share. Stop broadcast. Okay. Can you guys see my PowerPoint? Can you see my PowerPoint? No? Okay. Oh, what happened? Sorry, let me stop sharing. Three, two, one, and broadcast. Okay. Okay, so you can check the graph cycloid, and there's a hypocycloid. It's more complicated to function. You see that? Again, like this is something if you have interested in, you can talk about this later. There's a very interesting math topic, topology. They're gonna talk about this more in the future. But calculus 3 we just introduced. Yeah, there's a cycloid and hypocycloid, and then it's gonna be looks like this. That's the shape. Like this is actually shape. Isn't it beautiful? And then as they change the ratio between A and B, like here, they can have more different type, like this shape or like star or very, very complicated shape you can see a lot. Okay, we call this hypocycloid shape as a part of the parametric equation. So I don't know, in Europe, if you go to church, you can see this kind of like shape a lot on the window. Maybe the ancient, they already know like parametric equation concept. I don't know. Is it interesting? So think about it and you can search more for your, if you want to talk about this, you can choose this as your project, as a final project, like where this actually used in our real life example. That's something we want to know, right? So I just want to introduce those interesting, hypocycloid and cycloid. And if you have interest in it, just to read the textbook more. They have more, history and things like that. But again, like looks like that. Ooh, this is so long and complicated, right? We are not going to talk about this, okay? Anyway, that's 1.1. We are done. Can we celebrate for a second? We finished 1.1 parametric equation. Congratulations, guys. So I try to give you guys the main idea, 1.1 parametric equation. Think about the concept. And for today, read syllabus. And I'm going to upload this video and lecture. I'm not going to upload the lecture note, just video. Because I already provide the empty, blank PowerPoint. You can download it. And then if you're ready, go to quiz 1.1 and please watch their extra videos you can watch in our module. They're all resources available for you. And meet and discussion, check it out. Everything is due next Monday, January 26th. And if you have any question, email me or post to our board, okay? So I'm gonna stop recording at this moment. So for the rest of the minute, those who have any question how to install Lockdown browser, I can help you here. Otherwise, I will see you guys next, not next, this Thursday, we're gonna continue to talk about 1.2. So the lecture looks like this, speed and like this style, okay? Happy, great dinner, everyone. Go and eat, and I will see you Thursday at 4 p.m. via Zoom. And I'll be here for Lockdown browser who those need help. Okay, I will stop recording. Bye, guys.
Bye. Thank you
Okay.
so much.
Thank you, everyone. Take care. If you need any help, lockdown browser, that's something you can stay with me. Okay, I'll be here 1 second. I'm gonna stop sharing. Okay, so I think we have a couple students, maybe have a question. So I'm gonna just 1 second. I'm gonna go to, where is our lecture? Canvas. Okay, I'm gonna go to Canvas. So those of you guys who are here, maybe you have question about the lockdown browser. Yeah. So I'm gonna share how to do it. Let's do it now. So this is Calculus 3. Go to module. Everybody go to module. And then once you agree, AI and this one, this is something you're gonna go. Respondents lockdown browser sample test page. Click. Okay. And then preview. I'm gonna see preview version as a student. Sorry, not this one. 1 second. Did I? Okay, it's not. So go to lockdown browser. I'm gonna click student view and take the quiz. And you're gonna type the passcode here. A1, B1C2 submit. And then click this one. This is a download, mark down. And then if you click download it and just click finish. Everybody's doing that. It takes a little time. So even though you're not going to finish here, I'm here Thursday again, so you can continue, working with me. So download it and install on your desktop or on your computer where you're going to take the exam in the future. So this is a Peralta Community College District lockdown browser. So once you download it, like a little app gonna pop up. I don't know if I can show you that one. It looks like this, lockdown browser. I will just gonna like that. So the image looks like this. I'm gonna share through Zoom. Oh, stop sharing. Did I share something? Okay. So this is gonna be lockdown browser. If you go to chat, this is a lockdown browser that you downloaded. So click this. And then you are required to, they're gonna show you the page, Peralta student page. And then you're gonna log in again to go to student portal. And then you can go to Canvas and then that's gonna be your lockdown browser. Are you guys okay?
Oh, I had a question about the extra credit.
Extra credit?
Yeah, for the learning center, like I noticed you provided the Zoom link. Do you know like what the hours are for like the Zoom link?
Yeah, so if you go to Learning Center, the Mary College right now, Learning Center, they have a lack of tutor for math. So if you can go to BCC, Laney, Alameda, they also have a Learning Center and math tutor. You could go to any Learning Center at PCCD because they can keep track of your visiting hours, and then you can submit the information how many hours your visiting hour were there at the end of semester. That could be your extra credit. So for now, I can go to the learning center. If you go to Mary tutoring appointment, I don't think they update the schedule for 2026 spring. So you see that there's no math tutor here right now. So what I'm saying is you could go to BCC or Laney as well, or Alameda. They also have a math tutor.
So do I just search up like learning center?
Yeah, you could do Berkeley City College Learning Center, or Laney has a more option, I think.
Oh, okay. And then also for like the 110 study hours, that's like on the quizzes, the homework, and the tests, right?
Yes. So like you guys gonna be on Canvas with me at least like 3 hours per week. by participating in the Zoom session, and there's a weekly assignment that's extra 2-3 hour. So if you spend every week at least 6 hours times 17, that's 105 hours, 103, or 105 hours. But if you spend 110 hours on Canvas, I can give you guys extra credit because I can keep track of your logging in and logging out time.
Oh, okay.
As an instructor, I can see like this student spent like 48 hours, or this student spent. So just keep on doing your work. It automatically, naturally, you're gonna earn like more than 110 hours after the semester. So I don't worry about that if you really participated.
Okay. Thank you.
Yep, sounds good. Anybody has a question? Jackie or Sierra? Yes.
Okay, I do. I have work at the time of a meeting on Thursday. Is it possible? What happens if I miss the meeting?
Oh, so in that case, I'm gonna upload the video, so you're not gonna get any penalty because so I really want to see everybody's participation because there's a participation point, so you guys gonna earn participating points. But if you cannot make it on Thursday, that's fine. That's fine. But I want you to really watch the video later.
Yeah, I'll do that.
Yep, no worries. Okay. I
Mhm.
think somebody joined right now. Anybody? Hi, Edison. Come back.
Hello.
And yeah, anybody has question?
I do.
Yeah. Oh, sorry, you can go. So I was wondering, for the test is gonna be March 2nd and March
Monday.
2nd. Okay. So I think on the Canvas schedule it says it's on February 23rd.
Where is it? Can you share the screen?
Yeah. 1 second.
So test 1 will be March 2nd. Yeah, test 1, the link.
Oh, the link. Okay.
I didn't publish it, so you don't see any information, I think. But yeah,
Oh,
look
okay.
what happened.
You're sharing the screen again.
Yeah, I'm sharing screen.
No, you're not.
Okay, so it's March 2nd. I'll write that down.
Yeah. So no worry. As we get close to the date, I will make the big announcement. Test, 1 will be on March 2nd, but I already mentioned it on our syllabus. So please arrange the schedule accordingly. So it's gonna be available from 6 a.m. to the midnight. You can take it like early morning, or you can take it late night, but don't take it after like 11 p.m. because you have a lack of time to finish the exam, because the
Okay.
exam anyway gonna shut down at 11:59. So take it like at least to 9 p.m. because I'm gonna give you guys 90 minutes.
90 minutes?
So you have to have at least 90 minutes before it's shut down the Canvas test. But I think March 2nd should be fine Monday because we don't have a lecture. And you guys take it anytime, any place during the time period. So, but if you guys have any like difficult situation, email me. Okay.
Okay.
For
And
example,
for,
yeah.
do you know what the date would be for the second test?
Yeah, if you go to syllabus, can you click the
Oh, yeah.
syllabus?
Okay.
The left tab all the way up. Yep. So there's go down, down, down. Down, 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 down. Yeah, right.
Oh, okay. I see.
No, that's project. But
Oh.
go down, down. There's a number
Okay.
3, 4, 4, 4. Go down, down, down. Right there. Test. Yeah, right there. March
Oh, okay.
2nd, April 13, and May 19. So that's like pretty much 99% sure. That's the state test to date. I don't think we don't have any changing schedule, so that's what it is.
Okay, and for the final, would that also be asynchronous or will it be like during class?
It's gonna be, you're gonna take it with the lockdown browser without me. So
Okay.
just we're gonna meet every Tuesday, Thursday. Test will be happening on Monday.
All right.
So March 2nd, April 13, May 19, they're all Mondays. So yeah, so make sure how to install the lockdown browser. Without that, you're not eligible to take the exam.
Okay, got it. Yeah.
Yeah, so just try now lockdown browser right now. So that's what I'm helping other students. So can you go to module?
Module, yeah.
And then go down. There's a lockdown browser sample test page. Yeah, and then take the quiz. Yeah, copy that. And enter. And now don't save it. Yeah, don't save it.
Yeah.
And then click download it.
Okay.
The last one, the Peralta Community College District. Yeah, download it. And they're gonna ask you
I have
install.
it.
Yeah, you
This
can
one.
do it now or anytime before test.
Okay. Oh, I think the lockdown.
Oh, you already have it?
Yeah, I think I already have it. Okay.
Great. So can you show us, like, you when you just go to the lockdown browser, what happened? What is the first page it look like? They don't show us, right?
Yeah, it just says like I don't.
Oh,
'Cause
since
now
it
I
is a
can't,
lockdown, we cannot
Yeah.
share. Yes, you're right.
and I can't
Okay.
see the Zoom anymore. So
Yep.
I have to-
There we go. I
yeah.
think you are already ready to go, for test. Thank you.
Okay, thank you.
Yep. Bye-bye.
Bye.
Okay. Arika, Anisha, Jackie, are you guys okay?
Oh, I was just gonna ask, like, I was only able to join today because I was sick, but like usually I have work during the Zoom meetings, so would I still be able to get my participation points?
Yeah, I will. Can you email me when is your work schedule so that I can take a look at when I rate the participation point?
Yeah, okay. Okay.
No worries. Akira, do you have any question?
Hi, Professor.
Hi, how are you?
My question, hi, can you hear me, Professor?
Yes.
Hi. My question was more about like the environment inside of lockdown. Um,
Mm,
thanks to the last student that shared the screen, I see that it's connected to a specific browser that's downloaded, that we download to it, and our tests are available on the site. My question had something to do more about like the weekly assignments or quizzes.
mm.
If everything submitted would respond as lockdown,
Nope.
just the test.
Yes, just tests. So quizzes, other assignment, they're just regular Canvas page. There's no lockdown browser, so you don't need to worry about it. And it has unlimited, I think 3 attempts with unlimited time, so no pressure, no anxiety.
And
Yeah.
is this like more of like this is more of like proctoring, or is this is there like a scanning device that's involved in
Oh,
uh
for a weekly assignment?
no, for the lockdown? Is that like a proctoring
Oh, yeah.
tool?
Oh, I see. What does it look like? So there's no like in-person proctor. They just block you to go to another tab. So you cannot open any other like Google. You cannot open any tab. For example, I can show you. So if I go to our Canvas shell, so do you see our Canvas shell? So when you install the lockdown browser, they're gonna give you like program you need to click. So when you hit the click, you have to log into Peralta again by typing student ID and password. Okay, and then they don't allow you to go to open any other tab like this. Just only Canvas page. That's it.
Oh, lockdown. Got
Yeah,
it.
lockdown. So lockdown means you're stuck in the same page.
Great,
Yeah.
great. Thank you so much.
Yeah, so yeah, not like really like I'm monitoring, like, but still nowadays a lot of CSU and UC require more like proctoring, assessment for exams. So we are not 100% asynchronous. So I'm giving you the live lecture plus lockdown browser going to help you anyway. We are making sure that you're taking the task independently, not relying on any other external link, right? So that's what we are trying right now. But I think this semester many instructors are using different type of assessment for exams and modality. For me, I'm using Peralta lockdown browser for you exam assessment.
Got it. Thank you so much.
Yep.
I have a quick question.
Yes.
So you said for the lockdown browser, we'll need to remember our Peralta student ID to log in on the lockdown browser.
Yeah, I think when you open the lockdown program, they're gonna ask you to log into Peralta ID by typing ID and password, wasn't it?
It didn't have me log in, but I didn't open it. Actually, I didn't open it like from an assignment, so.
Yeah, yeah. Just try later. When you just go to lockdown browser, and then the first page will be like a Peralta college website. One like college website, and then from there you're gonna click student, and then second tab Canvas, and then to log into Canvas you should know your ID and password. That's what I mean, like a school email and password.
Oh, okay, I see. Thank you.
Yeah, like you don't need to show your ID on camera, nothing like that. Just you need to log in through the Peralta website, you
Mhm.
know, to get the Canvas page, because lockdown means you're not gonna jump into other pages. So try it. It's not really complicated, but I
Okay,
want to
yeah.
make sure when you're taking the test, I want to really make sure you're not gonna open any other tab.
All right, got it. Thank you so much.
Yeah. Jackie, do you have any question? Hi, Jackie, are you there? Okay, I don't think you're there. Do you require webcam? No, we don't need any webcam. Nope. Okay. If you're not there, I will close this meeting, okay?